Dear students, in continuation with the series of numericals, we have another numerical. Now, while doing numericals in previous lectures, you have seen how we have to solve the numericals. Now, see here, we will go through this numerical, or we can have it in form of MCQ also. So, it will be helpful for you for a competitive examination. And your approach would be like that. So charges, the figure is given to us. The charges plus q and minus q are placed at points A and B respectively, which are at a distance between them is 2x. The distance between them is 2x between A to B. Determine the work done in bringing a positive q charge along the path CRD is given by this. Now if we go through this figure, this point C, which is at a equal distance. So if we calculate the charge because of this, so we can say VA, because of positive charge, it is 1 upon 4 pi epsilon naught into Q upon X. And because of this B, which is a minus Q charge, that is VB is equal to 1 upon 4 pi epsilon naught into Q upon X, and is some negative nature, so we have substituted minus sign. So total potential at C, that will be VA plus VB. So finally we are having, because if we add these two, finally we are having 0. So at C potential is 0, but what we need to know, we need to calculate the potential at this point D, because of this charge and this, and because of this charge at this. So once we have got this, we are carrying a charge from here to here in this path. Okay. So first of all, we need to calculate the work done. We have to calculate the work done. Before that, we need to know the electric potential at that point, because when you will carry it, the work done will be done because of this. So here we can say the potential VD because of this charge. So if we calculate this distance 2x and plus x, because it is a circular path, so its radius will be x. So VD will be given by 1 upon 4 pi epsilon naught because of A, that will be Q plus, and the total distance is 3x. And because of this B, so I am adding it with 1 upon 4 pi epsilon naught minus Q, and the distance is from here to here, it is x. So the potential because of these two charges, that we will have 1 upon 4 pi epsilon naught, Q is taken common, so it is now 1 upon 3x minus 1 upon x. So we have here, it is, yes, it is x, it is minus 3x, and in denominator we will be having it is 3x, it is 1, and it is minus 3. So finally we will have Q is equal to 4 pi epsilon naught VD, that is minus 2 times Q upon this 12, or we can say minus Q upon 6 pi epsilon naught into x. This is the electric potential which we are getting at D. Now once we have got this, we know the electric work done in terms of electric potential will be work done per unit charge. So work done will be given by, now we have to calculate the work done. So work done will be the potential at D, that is VD, and the charge. So we are carrying a plus Q charge. Okay. So VD multiplied by the charge will give the electric work done to from year to year. Okay. So VD which we have minus 6 4 pi epsilon naught, sorry, minus q upon 6 pi epsilon naught into x into q. So it is minus q times q upon 6 pi epsilon naught into x. This is the work done. This is the final answer which we have. Now if we go through the option, we have this answer. So minus q into q upon 6 pi epsilon naught into x. This is this. Okay. So this way we have determined the work done from here to this. So you can also opt for the numericals and you can send the queries to. We will try to solve your numericals also. So please try to share with your classmates the link as well as subscribe the channel so you'll get more benefit